Let's look at the bromination of trans and cis 2-butene. Let's focus on the stereochemistry of the products from this reaction, because it turns out that in this reaction one of the two products formed is a meso compound, whereas the other is not. It can exist as a pair of enantiomers. Now, we know that when we do this reaction, it proceeds through a bromonium ion. And I want to focus on the trans 2-butene reaction first. In this bromonium ion, you'll notice that the relative stereochemistry of my substituents on my double bond is maintained. So these substituents were trans to one another. In my bromonium ion, they're still trans to one another. One is pointing out towards me, one is pointing back away from me. We can look at that in 3 dimensions using this model here, where we show the arrows of the electrons moving from the double bond, and this bromine, positively charged bromine ion, using some of its lone pairs to form the next bond to this carbon. And when we do that, we get an intermediate that looks like this, where we get this bromonium ion. I've drawn the positive charge on the bromine, but it's probably shared by all 3 atoms in the ring. And you'll notice that this methyl group is going back away from me, this is coming out towards me. The stereochemistry is maintained. This bromonium ion is attacked from the opposite side of where the bromine is. The bromine is shielding one face, and the negatively charged bromide ion comes in from the opposite face. We can see that here. I've shown the arrows like this. And we can look at what the product is on the other side, and you'll notice that the bromine that comes in here is facing down. The other bromine is facing up. They are anti to one another. And we could actually look at the product over here. And as I said, if we visualize it in a Newman type projection view, one bromine is up, the other is down. They're in anti-orientation to one another. So that's the product from the trans 2-butene. Let's do the same thing for the cis 2-butene. I form my bromonium ion again, and again the stereochemistry in the bromonium ion is the same as the starting alkene. These were cis to one another, they're still cis to one another. We can see that over here in my bromonium ion. Both my methyl groups are going away from me. We can look at the incoming bromide ion attacking from the opposite face of the bridging bromine, like this. You can see this comes in, that leaves. Can display it on my 2-dimensional models as well. Bromine comes in, this bromine leaves. The 2 bromines are anti to one another, and if we look at that on the other side, and we can see one going up, one going down. Again, in a Newman type projection, they are anti to one another, but notice that the 2 methyl groups are cis to one another this time. So those are our 2 products. Let's analyze the question we started out with, though. Which of these is a meso compound? And there are 2 different ways we can do this. First, we can assign the stereochemistry to all 4 of our stereocenters in the 2 products, 2 over here, 2 over here. So let's actually do that. Here are my 2 products. This is from the trans, this is from the cis. I've assigned the priorities of everything here. So for instance, if I start here, this is 1, this is 2, this is 3. And as this arrow shows for the first stereocenter here, going from 1 to 2 to 3, we're going in this direction, which is clockwise. But notice the hydrogen, the 4th priority, is facing towards us. If I rotate this molecule so it's going away from us, like I want it to be, 1 to 2 to 3 gives me counterclockwise, or S. Notice that the first stereocenter in the cis product is the same as this one. I haven't really changed anything here, so both of these are S. I can do the same thing at this second stereocenter. Going from 1 to 2 to 3, I'm going in this direction. 1 to 2 to 3. Notice that our lowest priority, our hydrogen, is also already going away from us. So this is going in that direction, which is clockwise, making this stereocenter R. So this one is SR. The other one, the other stereocenter in my cis, is the opposite of this. So this is S, so we have our SR and our SS. And as we know, it's going to be the SR compound that is the meso compound. There's another way we can look at this if you're not convinced. I have my trans and my cis product drawn here, and I can actually rotate around this bond. And when I do that, you can see for the product that was trans, I get a molecule that has a plane of symmetry right down the middle. But if I did the same thing for this one, I don't get that. So the product from the trans 2-butene is the meso compound.